Mercury is a little planet, but it's given evolutionists some big surprises. First occurred when the Mariner 10 space probe first visited Mercury. We measured the planet's gravitational pull on the probe, and we took some other measurements at the same time. We discovered that Mercury is extremely dense. There's a lot of material in a small space in Mercury. In fact, it's the highest known density of all planets except Earth. The problem is Mercury is too small to have such a high density. It's small enough to where it doesn't have a large gravitational field, thus should not have compacted all the material to such a density. In fact, we believe that up to 75% of the radius of Mercury is represented by an iron core, which is this thing here. So in this little cutaway view, if this is the planet, then this is one big ball of iron on the inside. So Mercury is mostly a big ball of iron wrapped in a few rocks. Now this is a big problem for evolution, though. Evolutionary nebula theories say that Mercury can't be this dense, not even close to it. And this has caused evolutionists all sorts of fits trying to accommodate it into their model. Here's a quote from an evolutionist. He says, "The driving force behind previous attempts to account for Mercury has been to fit the high density of the planet into some preferred overall solar system scheme. It has become clear that none of these proposed models work." And so how do they explain this? Okay, Mercury doesn't fit into the evolutionary model. Well, the high density is conveniently accommodated by the large impact hypothesis, which makes Mercury unique. Well, what is a large impact hypothesis? Basically, it's the idea that since evolution can't explain Mercury, because the planet has to be far less dense than it is, therefore, since we know evolution is true, Mercury must have formed according to the evolutionary model. But early in its history, one of those asteroids that we saw circling the sun crashed into it. Now, all the lighter material was stripped away and dissipated somehow, leaving behind only the dense material that we see today. Okay? So Mercury today doesn't match evolution. Since we know evolution is true, therefore it must have used to match evolution, if I can butcher grammar a bit. But an asteroid crashed into it and changed it to what we have today. So where's the evidence for this collision? Well, back up a minute. This is the solution to the problem, okay? One of these asteroids that we saw earlier forming along with the planets smashed into Mercury, and all the stuff that should have been there just went away somewhere. So what's the evidence for this model? Well, only that if it didn't occur, Mercury would disprove evolution. Anybody see a problem with this? But that wasn't enough. Mercury gave evolutionists another rude jolt when Mariner 10 also discovered that Mercury has a magnetic field. Problem is, according to evolution, it can't have a magnetic field. And to explain why, I'm going to get into some geek stuff here. Forgive me for a minute. The only way for a planet to have a magnetic field, actually back up, the only way for a planet with a magnetic field to be billions of years old is currently known as the dynamo theory. The dynamo theory says that there is liquid inside of a planet that conducts electricity and it's moving around, and that motion creates a magnetic field. And I won't get into details because it's a complex thing. The important thing for tonight is that it requires that all planets which have magnetic fields also have cores made up of molten metal. Metal that's melted, liquid. And as I said, fluid motions inside this liquid core can supposedly generate a magnetic field around that planet, which, like I said, is a complicated process. I won't bore you with details. So, let's summarize that up here. In order for a planet to be billions of years old and still have a magnetic field, there must be fluid motions inside of its core. Therefore, the core itself must be molten and has to be fluid. But, as one evolutionist says, Mercury is so small that the general opinion is that the planet should have frozen solid eons ago. Therefore, Mercury's core cannot be molten. And so evolutionary theories say that Mercury can't have a magnetic field, but it does. Now, I probably lost at least some of you in the details there, but the important thing is evolution says there can't be a magnetic field, and when we sent a space probe to visit that planet, it did have one. So how do they get out of this? Well, here's the proposed explanation. A pure iron core would have frozen long ago, like I just told you. So the most likely candidate is an iron sulfide core. In other words, the core isn't pure iron, there's some sulfur mixed in with it. The presence, okay, now, sulfur would allow the core to cool more slowly, okay? But the presence of the volatile element sulfur as a constituent of the planet closest to the sun, and I'll wade through the jibber-jabber here in a moment for you, has important implications for models of planetary accretion. If mercury contains a substantial sulfur content, then this removes much of the rationale for heliocentric zoning of nebular composition. I'll read the rest of it. Models in which mercury accretes from high-temperature components only are no longer viable. If the innermost planet has a substantial volatile component, there is little basis for condensation models of planetary accumulation based on heliocentric distance. What does all that mean? Well, if you think of when I told you about that big swirling cloud of gas and dust and how the closer you are to the sun, the hotter it is, and so certain elements can't have condensed into planets there. Well, one of those things that can't have condensed into a planet is sulfur, because sulfur is very volatile. So to rescue mercury for evolutionary theories, mercury has to have had, or has to have, actually, today even, sulfur in its core. But the whole nebula theory says that you can't have sulfur in a planet that close to the sun. So let's summarize this. In order to preserve a billions of years age for mercury, evolutionists speculate that it has an iron sulfide core. But the nebula theory says volatile elements like sulfur can't be this close to the sun. So in trying to rescue mercury for their evolutionary theory, they've undermined the entire theory. Did my mic just go? It went up for a minute. Now, as creationists, we don't have a problem with this. There are other methods for a planet to have a magnetic field than the dynamo theory. The problem is none of them can last for billions of years. It's very possible that if Mercury was created with a magnetic field initially, that field could still be there today in the form of remnant magnetism. And actually, that explanation makes sense for a lot of the planets, as we'll see as we go. But the only way to get one that lasts billions of years is this dynamo theory business that I just explained to you. And Mercury says, doesn't work. So here's what you aren't being told about Mercury. Next time you see a science program about Mercury and how it evolved, this, that, and the other, here's what you aren't being told. Number one, evolution says it can't be dense, but we found out it is. Number two, evolution says it can't have a magnetic field, but it turns out it does. And trying to rescue evolution from the facts just makes the problem worse, as we saw. When you change your model of Mercury to make it fit in the billions of years, then your entire theory blows up. Mercury is indeed the tiny planet that causes huge problems for evolution. 1 Corinthians 1:27 comes to mind, but God has chosen the foolish things of the world to confound the wise, and chosen the weak things of the world to confound the things which are mighty. Next to Mercury, further out from the sun, is the planet Venus. Now, if you look at Venus in a telescope, you won't see anything like this picture here. This picture is actually generated from measurements we've taken of the planet's surface underneath its cloud cover. Venus actually looks more like this because Venus is totally covered in clouds. In fact, those clouds make Venus a very unpleasant place to be. The atmosphere is mostly carbon dioxide, and the clouds are mostly concentrated sulfuric acid. So you don't want to be breathing the air in Venus. The carbon dioxide causes a massive greenhouse effect, which makes Venus actually the hottest place in the solar system. It's not the closest to the sun, but it is the hottest place. 900 degrees Fahrenheit on the surface of Venus. There have actually been a few spacecraft landed on the surface of Venus. They don't survive very long, a matter of a couple of minutes. If you can imagine trying to engineer something that when you land it, the solder starts dripping out of your circuit boards, you can appreciate the engineering problem that these people had. But we have actually, as I said, landed a few. The Soviet Union, back when it was still around, actually did more with Venus than we did. The pressure on Venus is 90 atmospheres. So if you imagine a place where you're breathing sulfuric acid, you're in a nice cool 900 degrees Fahrenheit and being crushed by 90 atmospheres of pressure, the biblical description of Hades comes to mind. Now, Venus is often called Earth's sister planet because it's very similar to the Earth in the size, mass, the stuff it's made up of, and its location in space, because we're right next door to Venus. Now, evolution says that Venus should actually be very similar to Earth because both planets supposedly formed at the same time, at the same place, from the same materials, by the same natural processes. So since there's no interference by a creator, they should be roughly the same, right? Well, they are similar, as I said, in size, mass, and composition, but Earth has a crust made up of multiple tectonic plates. Venus only has one. So there's a glaring dissimilarity in the structure of these two planets. Also, Earth has a magnetic field. Venus, as it turns out, has none. They've looked for it. It should be there, but it ain't. So even though the dynamo theory says that it should have one, it doesn't. Other problems for evolution. Venus's surface is very young and fresh. It doesn't have billions of years of erosion, apparently. The few spacecraft